This is slide 15, and we already basically talked about this. On the next slide, I just wanted to point out to you this strange little fact. It doesn't really matter if you say X is between C and D non-inclusive. And non-inclusive means the endpoints aren't included. And this means probability that X is between C and D inclusive. And that means the endpoints are included. Included. So why does it not matter whether the endpoints are included or not? It's because the probability of any single value is 0. And so if we include C or don't include it, it doesn't even matter. Kind of tricky, because back when we were in our discrete probability distributions, it mattered whether or not we included a specific value. So in a way, the continuous probability distributions are easier. It's a little less picky. This slide is just exactly the same again. So that's fine. The next thing I wanted to go over is 3 different continuous probability distributions. The first one is the uniform distribution, which will be on the next page of your worksheet. The uniform distribution just means that all the values are equally likely. In this case, all values between 2 and that looks like 8.7 are equally likely. So this probability distribution is totally flat. It's not like there's a more popular part or a more likely part and a less likely part. It's just the same all the way across. And then somebody shaded the area between 3 and 6. So we could be looking at the likelihood of landing between 3 and 6, but the entire distribution is from 3 to 8.7 or whatever that is. The exponential distribution we're not going to cover, but I just wanted to show you that we could have a distribution that's curved like this. And then we could say, what's the probability of landing between 2 and 4? And we would find that shaded area. And here's our favorite, the normal distribution. And so again, we already did this. These integers represent standard deviations. The mean is right here, and we're going to get into this in chapter 6 even more. The mean is the center. So out of all 3 of these distributions, which one would be the easiest to find the area? Of those 3 shaded purple areas, which one can we actually find? See how these are weird shapes, but this is a rectangle? The area of a rectangle is length times width. So this would be, how long is that? That's 3. And then we could find the area by multiplying by the height. So this is the easiest to find the area, or the shaded area. Shaded area, and the shaded area is the probability. So my guess is the reason that we included the uniform distribution in chapter 5 is just because it's really easy to find the shaded area under there. And now I believe we are ready to tackle the question on the 3rd page of your activity sheet. This graph represents the fact that all x values between 0 and 20 are equally likely. So I'm going to go over to our worksheet and continue from there.